Hello kings and queens, I hope you're all doing well. So in this video today we are going to discuss about the topic linear programming problem. So under that we are going to discuss about the topic graphical method. So when we take a linear programming problem there will be a various of methods. So under that we will just discuss about this graphical method today. So before starting the problem, let me give a basic introduction about this linear programming problem. So when we take an organization, there will be major two objectives, that is minimization objectives and maximization objective. When it comes to a minimization objective, the organization will make effort to minimize the cost of production, that is the expenses which is incurred in producing the products. So when we take the maximization objective, the organization will always make efforts and also formulate strategies to improve the profit of the organization. So this linear programming problem helps to identify the minimization point where the organization can reduce its cost of production, and also the maximization point where the organization can increase its profit. So without any further delay, let's get started. Question. So when it comes to a graphical method, it is just applicable only when we have two variables. So the variables here are x1 and x2, right? So when we have two variables, then we can use this graphical methods. When we have more than two variables, this method is not suitable. So in this question, this is the objective function. And this is the constraints. And the condition is like x1 and x2 values should be greater than or it should be equal to 0. So this is the condition. So using this question, let's solve the problem. So solution. So now we will be using these constraints, that is 10x1 plus 20x2 lesser than or equal to 120 and 8x1 plus 8x2 lesser than or equal to 80. So using these two constraints, we are going to identify the x1 and x2 values. Okay. First, let me take this first constraint. This is the first constraint and this is second constraint. Okay. First constraint is 10x1 plus 20x2 lesser than or equal to 120. Now let me transfer this to 10x1 plus 20x2 is equals to 120. So I will transforming this constraint into a equation. Okay. Now I have to identify the x1 and x2 values. But the thing is, I don't know x1 as well as x2 value. So what I will do is, first, I will consider x1 as 0 and I will identify the x2 value. And after getting the x2 value, I will consider the x2 as 0 and I will be identifying the x1 value. Now, I don't know the x1 and x2 values to compute this equation. So, what I will do is, first, I will consider x1 as 0 and I will be identifying the x2 value. After identifying the x2 value, I will be considering the x2 as 0 and I will be identifying the x1 value. So, let me show it. When x1 is 0, what is x2? So let me write x1 as 0 and let me identify this x2 value. So 10 into x1 is 0 plus 20 into, I have to identify the x2 value. So I will write x2 as same is equals to 120. Okay, let me draw a box here. X1 and x2. Now I have taken this x1 as 0. So now I have to identify the x2 value. So 10 zeros are 0 plus 20x2 is equals to 120. So 20x2 is equals to 120. x2 is equals to 120 divided by 20 is in multiplication form. When we transfer this 20 to this side, it will become in a division form. So 26 za is 120. So x2 is equals to 6. So when x1 is 0, x2 value is 6. Okay. Now what we have to do is, now we have to consider this x2 as 0 and we have to identify the x1 value. When x2 is 0, what is x1? Okay, so using the same equation, we have to identify the x1 value. 10x1, I have written x1 because now I have to identify the x1 value, plus 20 into x2 value is 0 now, is equal to 120. So 10x1 plus 20 zeros are 0 is equals to 120. So 10x1 is equals to 120 because this is 0, right? So 10x1 plus 0 is same. So 10x1 is equals to 120. Now x1 is equals to 120 divided by 10, which is equal to 12. Okay, so x1 value is 12. When x2 is 0, x1 value is 12. Okay, when x1 is 0, after computing I have got x2 value as 6. Okay, when x2 is 0, after computing I have got x1 value as 12. Okay, so this is all about the first constraint. Same thing we have to do with the second constraint, that is 8x1 plus x2 lesser than or equal to 80. So the second constraint is 8x1 plus x2 lesser than or equal to 80. Now I have to convert this to an equation, plus 8x2 is equals to 80. Okay, now same thing I have to do when x1 is 0, what is x2 value? So 8 into x1 value is 0 plus 8, x2 value I have to identify, so I will write the same, is equals to 80. 8 zeros are 0 plus 8 x2 is equals to 80. So 8 x2 is equals to 80. x2 is equals to 80 divided by 8, which is equal to 10. Okay, let me write the box. So when x1 x2, so when x1 is 0, the x2 value is 10. Same wise we have to identify when x2 is 0. When x2 is equals to 0, what is x1? Okay, so 8 into, we have to identify the x1 value, plus 8 into x2 value is 0 is equals to 80. So 8x1 plus 8 zeros are 0 is equals to 80. So 8x1 is equals to 80. x1 is equals to 80 divided by 8, which is equals to 10. Okay, so when x2 is 0, the x1 value will be 10. So using these values, we have to plot the graph. Okay, so this is our graph. If you do in a graph sheet, even you will get a more accurate answer. So if you do in plain sheets also, you will get an accurate answer, but it will be a point or a minute, there will be a minute difference in that. Okay, so let me mark this. Here it is 0, 1, 2. Already have marked the centimeters, so I'm just naming that. 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. You also have marked, let me name it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So this axis we represent it as x axis, x1 axis, and this as x2 axis. In some questions they will give variables like x and y. In such situations you mark this as x and this as y. So in this question they have given variables like x1 and x2. So I have marked this as x1 and this as x2. Okay, now what we have to do is, first chart we have to see. So this is the first chart. When x1 is 0, x2 is 6. So when x1, this is x, right? So this is x1. So when x1 is 0, x2 is 6. I have to mark to, this is x2 axis, so I will mark 6. Okay, now I cannot draw the line. Next I have to see, when x1 is 12, x2 is 0. When x1 is 12, x2 is 0. When x1 axis is this, so when x1 is 12, x2 value is 0. Now I have got two values from the chart where I can join this. Okay, so 6 to 12. Okay, let's see the next chart. So the next chart is this. So when x1 is 0, x2 is 10. So when x1 is 0, x2 is 10. When x1 is 10, x2 is 0. x1 is 10 and x2 is 0. Okay, I have got 2 points. So I will join this as well. Okay, now we have to shade the region. Okay, feasible region. We have to identify the feasible region. For that you have to see the question. The question is like lesser than or equal to, lesser than or equal to. So they have given like lesser than or equal to. When they have given lesser than or equal to, it indicates that you have to shade the region below the lines. If they have given greater than or equal to, I will teach you like how you have to do when they have given greater than or equal to in the constraints. So in the constraints they have given like lesser than or equal to. So when they have given lesser than or equal to, you have to shade the region below the lines. So this is the second constraint line and this is the first constraint line. So the region which lies below these two lines is this, right? So I cannot take this region because this region is just for the second constraint, and as it is the region which lies below the first constraint. So this is the region which is common to both the lines and which lies below those lines. So I will shade this region. So when they have given lesser than or equal to, you have to shade the region which is below the lines. When they have given greater than or equal to 0, then you have to shade the regions above the lines. Now they have given lesser than or equal to, so I will shade the region below the lines, below the two lines. So below two lines the region is this, so I will share this region, and this is the feasible region. And we have to mark the corners of feasible region. So this is the feasible region and I have to mark the corners of this region. The corners are this, and this. Just the corners of the feasible region. This is also a corner, but it is not a corner of feasible region. Just have to mark the corners of the feasible region. The corners are this, and this. So I will mark this as A, this as B, this as C, and this as D. So the A value is 0 and 0 because A lies in the 0 corner. So the A value is 0 and 0. So when it comes to B value, the x1 value for B is 10 and the x2 value is 0. And so now we have to mark this D value where x1 for D is 0 and x2 is this, right? So this is x2 axis. So x2 value is 6. We have to identify this C value where x1 value for C is 8. So if you do in graph, you will get an accurate answer and there is a minute difference in this. So the x1 answer is 8 whereas the x2 value is you have to see the intersecting point. So the x2 value is 2. So this is the x2 axis, whereas the x2 value is 2. So x2 value is 2, 8, 2. Okay. Way to identify this x1 and x2 value is, first you have to find the x1 value and then x2 value. We can mark like this so that it will be easy. First x1 and x2, x1, x2, x1 and x2. You can even write this value at the time of plotting the graph itself. So otherwise you can even write after plotting the graph. Okay. So now what we have to do is we have to write the objective function, that is z is equals to 12x1 plus 16x2, and we have to write all the corners. So the corners of the feasible region is A, B, C and D. We just have to consider the corners within that feasible region, not the corners outside that feasible region. Okay, so the A corner value is 0, 0, B is 10, 0, C is 8, 2 and D is 0, 6. So 12 into x1 value is 0 plus 16 into x2 value is 0, which is equals to 0. And 12 into x1 value is 10 plus 16 into x2 value is 0 is equal to 12 tens are 120 plus 0 is equals to 120. And 12 into x1 value is 8 plus 16 into x2 value is 2. So 12 8s are 96 plus 16 2s are 32, which is equals to 128. Okay. Next 12 into x1 value is 0 plus 16 into x2 value is 6. 12 zeros are 0 plus 16 6 are 96. So 0 plus 96 is equals to 96. So these are the values which we have got from the feasible region corners. Okay, we have applied the feasible region corner values to the objective functions and we have got values like 0, 120, 128 and 96. Okay, so these are the values which we have got, and the function, objective function is maximize z is equals to tell x1 plus 16x2. So it is a maximize problem. So what we have to do is we have to identify the maximum values over these values. So among 0, 120, 128, 96, the maximum, the most greatest value is 128. So the most greatest value is 128, which means this C corner. So C corner, the maximum value is 128. Okay. So at the end, you have to write the conclusion. The Z value is maximum at the corner C. So at the C corner, we have got a maximum value. So that is 128, where x1 value is 8 and x2 value is 2. So this will be our conclusion. So it's very simple. What you have to do is you have to identify the constraints, and using those constraints you have to compute the values by taking x1 as 0, and after that you have to identify the x2 values, and after that you have to compute x2 as 0 and you have to identify the x1 value. Same thing we have to repeat it for second constraint, and you have to identify the x1 and x2 values. You have to plot the graphs based on the values which you have got through the constraints, and after that you have to identify the feasible region. When they have given lesser than or equal to, you have to shade the regions which is there below the both lines. Okay, when they have given greater than or equal to, then you have to shade the regions which is there above the lines. Okay, next you have to identify the corners of the feasible region. After identifying, you have to identify the x1 and x2 values of that, and you have to compute it with the objective function. I hope you all like this video. If you like this video, do subscribe to Kingmakers and share this with your friends. All the best for your exam. And in the next video, we will be seeing the minimization problem on the graphical method. Okay, thank you all.